Okay, on the review in number 14, B, it says given the following system, you can solve using graphing, elimination, or substitution. Explain which method you would use and why. Well, I have x plus y equals 5, and I have y equals x minus 3. The easiest or most efficient method here that I would use would be substitution. I would use substitution because the variable y is isolated. It's already by itself, so I could take what it equals and replace it into the other equation. So I would use substitution because a variable is isolated. I'll just say in the bottom or second, you could say in the second equation. Then it's to solve the system using the method you chose in part 1. So that first equation would become x plus, and instead of y, we're going to replace it with x minus 3 equals 5. Combine like terms, 2x minus 3 equals 5. Add 3 to both sides, we get 2x equals 8. Divide both sides by 2, we get x equals 4. You can plug this x into the first equation or the second equation. I'm going to plug it into the second equation since we're solving for y. So x equals 4, and 4 minus 3 is 1. So we get the 0.41 is our solution. In number 15, A and B, we are identifying and describing the error made when solving the system. So let's see, in step 1, it looks like we take the 4x minus 2y, we replace this y with 3x plus 7. So substitution is being used. Step 1 looks good. Step 2, we have 4x minus 6x plus 14. Looks like they distributed. This is a negative 2 times 3x, which is negative 6x. Negative 2 times positive 7 is, should be a negative 14. So the error occurs in step 2. Describe the error using complete sentences. Negative 2 was not distributed correctly. We could say the plus 14 should be a negative 14. In part B, it looks like there's a variable that's isolated, and it looks like it was replaced with this negative x minus 4. So we used substitution here. Equals negative x plus 20. In the next line, it looks like things were distributed. Negative 5 times negative x is positive 5x. Negative 5 times negative 4 is a plus 20. Looks good. This all stays the same. In the next line, it looks like an x was added to both sides. Looks good. 5x plus x is 6x. Our plus 20 stays. This plus 20 stays. Then it looks like we should subtract 20 from both sides. But 20 minus 20 is not 40. 20 minus 20 is 0. So our error occurs in step 4. Let's see. 20 should have been subtracted from both sides of the equation, resulting in 6x equals 0. Number 16 says in part A here, part 1, Mr. Wright's solution to the following system is 3, 3. Check his solution. So remember, to check a solution, we're going to substitute 3, 3 into both equations. So in the first equation, 3 gets substituted in for x, and 3 also gets substituted in for y. So we get 3 plus 6, which equals 9. 3 plus 6 equals 9. We get 9 equals 9. So 3, 3 works or checks out in the first equation. But in order to check, you have to check both equations. So now I'm going to substitute 3 for x in the second equation and 3 for y. 3 times 3 is 9. Negative 2 times a positive 3 is a negative 6. 9 minus 6 is 3. 3 does not equal 30. So this is our check. It says, explain why Mr. Wright's solution is correct or incorrect. The 0.33 is incorrect because it does not produce true statements when substituted into both equations. Remember, it must work in both in order to be a solution.